Hello, everybody. Welcome to the latest episode of Insider's Guide to the Galaxy. We'll just give people a couple of minutes to flood in here. Your host today is Chris Vaughan. He's got some great stuff for you on how to read star charts, which some of my colleagues could use a refresher on, and some more Finest NGC. I'm your co-host, Charles Ennis. Don't forget to put in the chat where you're from.
Welcome far and wide. Fantastic.
Far and wide, yeah. Well, Chris and I are on opposite sides of the country almost, so I'm coming to you from the Sunshine Coast.
And I'm coming to you from sunny Thornhill, Ontario.
Yeah. Do you have a lot of smoke there today, Chris? We're starting to get some today.
The sky looked very blue this morning. I think the air quality was good here this morning.
Oh yeah, we're catching up to you with the smoke apparently today. We got some fires somewhere around here. I think we got just about 50 people. Let's start this rolling. Chris, what have you got for us?
Right, let's get this chat over. Here we go. So we haven't done this topic before. I thought we would cover off, just all about star charts, how they work, how to use them, some of my favorites. Charles will chime in with some that he's used as well, which is great. And I'm going to sort of pitch it as for beginners. So I'm going to sort of do the basics and not really focus or assume that everybody's used them for years. So we might as well explain how they work, what are some, recommended tips for using them as well. Before we do though, I thought I'd start with a little bit of background, a little bit of history. I'm going to share my screen here because I've got a reason to do this here in a moment. I'm just going to bring up my Stellarium here and start sharing that. Here we go. Because I think this is something I came across in my research that I think is really fascinating. I've been looking up for years, looking up at the sky for years and recognizing or connecting the dots with star patterns. They eventually discovered that the sun was tracing out a path through the stars along what's now known as the ecliptic, and the constellations that it was visiting came to be known the zodiac constellations. And of course, the moon does a similar thing, although it wanders from the ecliptic by up to 5 degrees. And people came up with the concept of lunar stations or lunar mansions. Those are sort of the nightly position of the moon as it journeyed along a similar track across the sky. Eventually, people began to realize that the stars were returning on the same nights of the year, so they could then establish the motions of the heavens into calendars, and we've covered that before in Insider's Guide to the Galaxy. And so, we're able to discover from time to time ancient relics or artifacts or proof that people were taking note of the sky and sort of capturing what they're seeing in the heavens, on tablets or on cave paintings and things like that. And one of the neat ones that I found was this, and I've written about this before in my skylights, is there's a cave called the Lascaux Caves, which are in France. And a researcher by the name of Dr. Michael Rappengluck has hypothesized that, that the cave paintings may represent the celestial object in the sky, particularly in this particular case. I don't know if you can see this too well, but this is a picture of a cow-like or a bull-like creature. And the little dots on the face here are thought to represent the Hyades cluster, which we know in modern day make up the triangular face of Taurus, the bull constellation. And then to the upper right here, you've got another grouping of about 6 or 7 stars that he suggests would represent the Pleiades. And I think it's a compelling case. This is dating from about 17,000 years ago, which is fascinating. And it's really something to go and dive deeper into if you're interested. This cave is full of depictions of various things. And then there's a more modern cave painting, which to me looks like a copycat. I think this dates around, well, maybe even older. So this one's saying it's about 20,000 years. So it's possible that one is a sort of a copy of the other, but you can sort of get that idea. Now, this is the one that really fascinated me. So he also suggested that in another part of the cave, there's a picture that represents kind of a bull and a long figure of a human, and then a bird. And he's suggesting that this represents the summer triangle asterism. So I'm just going to actually switch back to Stellarium here. My Zoom is doing funny things when I change things from window to window. Hopefully it's coming through okay. So here we've got Vega, Deneb, and Altair, the three bright stars of the summer triangle. And if you're familiar with the constellations, then you know we normally think of Altair as the eagle, Deneb as the swan, and Vega as the lyre. But I'm wondering if, let me just come back here. It's possible that Vega, along with some of the bright stars kind of over in this section of the sky, would represent a big figure. Let me just turn off the daylight here so we can see these a little bit better. So if you connect Vega and imagine it sort of traces out to the west here and connects with a bunch of these brighter stars and Hercules and Ophiuchus, you know, maybe that would represent a big figure, like a bull. You could maybe think of the Milky Way as the straw or the bedding, you know, under the bull, or the grasses that it's walking in. And then Deneb being the head of the figure, Saturn being kind of the heart, the wings of the swan being outstretched arms, and the figure kind of stretching down to the lower right, maybe Alberio being this kind of groin area, and then, you know, we've got Ocab being his feet. And then the Altair and the two stars to the north and south of Altair being maybe the wings of this bird. So I think I can see what he's driving at. And that's kind of a fascinating thing to think about. So that's just, I'm putting that out there as a possibility. Now we don't know when exactly the formal star charting began. Many cultures of the world have done it all independently of one another, and not everyone's artifacts have been preserved or kept. We do have old inscribed star maps that were dating from the Egyptian period, say 5th to 3rd millennium BCE. The Babylonians of Mesopotamia have some material that dates from the 2nd millennium BCE. And then there are some Chinese artifacts from, you know, in the 1st millennium BC, around 400 BC. Our modern constellation names and their depictions are typically arise from Greek astronomy. So you've got people like Eudoxus, Timocharis, Aristillus, all of which are craters on the moon, by the way. So if you do your lunar geology, you're going to find a lot of these names as craters on the moon. Building on their work, then this gentleman Hipparchus, who lived around 190 to 120 BC, produced a foundational star chart around the year 129, and he also generated some armillary spheres, which are the sort of, you know, metallic representation of the brightest stars in the heavens and that kind of thing around that time. And then after the 0 year, into the AD, early 80s, the 1st century after, you get the Greek astronomer Claudius Ptolemaeus, or Ptolemy, and he produced the Almagest. The Almagest is a famous star chart. And if you actually go into Stellarium here, if I can do this, go into your sky culture, you're going to find some of these in here. So there's the Almagest as an option. Let me just turn on the constellations. So you can actually reproduce a number of these ancient star charts by the various sky cultures that are embedded in Stellarium. So he actually produced star charts for about 48 constellations, some of the more famous ones that we're all familiar with even today. He mapped about 1,000 stars that were visible from Alexandria. And later on, the pre-Islamic astronomers in the Arabian Peninsula, including ones like Abd al-Rahman al-Sufi, updated his work, and around 964 AD, he produced something called the Book of Fixed Stars. And what was neat about his manuscript, there's no surviving copy of his manuscript, but there have been lots of reproductions around the world in various museums. And one of the neat things that al-Sufi did is he depicted each constellation twice. Once as viewed by humans looking up into the sky, and the other from God looking down on the celestial sphere. So the constellations are mirror images of each other. So if you've ever seen those globes that are plastic, clear plastic globes with the constellations and stars etched on them, you know, you're looking at those from outside, the constellations are all reversed than what you'd see from the ground. So that's kind of neat that he did that. So there are links online to various copies of his book. The Aga Khan Museum, I think, in Toronto has a book, has a reproduction of it. So it's kind of neat to look at. The oldest star chart manuscript, you know, not a stone tablet or something like that, seems to be something called the Dunhuang star chart, which is a scroll dating from the Tang Dynasty. So again, I recommend doing a little reading up or looking into some of these things that I'm just sort of touching on here. Now, Al-Sufi's work was foundational. It was used for hundreds of years by scholars around the world. It was updated by a gentleman named Ulugh Beg in 1437, and it wasn't really superseded until Tycho Brahe produced his star chart or his catalog in 1598. We're still dealing with about the 1,000 brightest stars in the sky at that point, and basically anything visible from, you know, the tropics and in the northern hemisphere. But then we get into the biggie, one of the biggies, which is the Uranometria, which was produced by Johannes Bayer in 1603. That contained 51 star charts. So we took Ptolemy's 48. He added a deep southern sky chart, which added about another 12 constellations. And then he also produced or published all sky charts of the northern and southern sky as well, for a total of 51. And at that point, that's where the you know, one of the earliest times when the Greek letter, you know, designation started to be used to identify the stars, you know, that didn't have proper names. Yeah. So I think I've got a picture of Orion here. I'll just open this one up and show you from Uranometria. Here we go. So that's the sort of thing you were looking at, you know, very classical looking art. You've got the star brightness is indicated by the size of the symbol, big stars, little stars. You've also got this dark band here, which represents the Milky Way, and some coordinates and things like that. We'll come back to what's on a star chart here in a little bit. So then Hevelius, the Polish astronomer Hevelius, compiled and produced a star atlas in around 1687. He produced 56 star charts, and he is responsible for adding on some of the constellations we're familiar today that were not original, things like Canis Venatici, the hunting dogs. Let me just go back to Stellarium here and put on the Western constellations. Gonna come up. Boom, here we go. So you've got Canis Venatici, Lacerta, the lizard, it's got Leo Minor, Lynx, Scutum, Sextans, and Vulpecula. So a lot of these lesser, you know, not as bright constellations that were blank patches of sky that he was welcome to fill in. Finally, we get to Flamsteed. So John Flamsteed was the astronomer royal, and he produced a work that he called the Atlas Coelestis. There's a funny story that Isaac Newton actually scooped him. They took basically his work and published it without his permission, and that created a lot of problems. He actually had to go around and collect the copies and burn them, I think, because he didn't feel they were worthy for production yet. But he later on passed away, and his wife posthumously published his atlas. Now, he used a telescope to compile his list of stars. So he actually added upwards of 3,000 stars in his catalog. A French astronomer by the name of Joseph Jerome de Lalande, he took Flamsteed's work, and then he applied the numerical numbering system that we see today in modern star charts. And typically the way those operate, just to kind of jump ahead a little bit, is you take the stars in a constellation, and you start with, again, he was only dealing with the sort of most prominent stars that he could see in a small telescope, but you basically start with the westerly stars. So those are the ones with the lowest right ascension. So he was ordering them in increasing right ascension coordinates. So the most westerly stars in a constellation will be the low numbers, like this one is 4. Take Izar, for example, it's 36. And as we head more to the east, the numbers are going up, 49, 54, and so on. So those are the Flamsteed star atlas numbers. I think I've got a picture of Orion here with depicted in this way, so you can get a sense of what that one looks like. So you're going to see in this one, it's in French because Lalande produced this, and you've got the Greek letters beside the major stars, and every once in a while, there's a number, but this particular graph didn't show too many of the numbered stars. So all we're basically doing is, as these developments or progress is made through the years, they're actually contributing to or adding to what we now use as modern star atlases. Now the Bayer designations are only good for the stars north of about Fomalhaut. So he wasn't viewing the stars. He was in Bonn, Germany, he was in Germany, so he wasn't seeing the stars that were very southerly in the sky. So you won't find the Greek letters produced by him in the southerly constellations. That they've later been added in by other people. And lots of exceptions exist to the Flamsteed numbering system because as constellation boundaries varied over time, stars were assigned or traded from between one constellation and the next, or the stars' proper motions shifted their positions a little bit east and west, then you can find some exceptions to the rules that he put together. Now, the era of full sky charts really kicked off. So, these gentlemen were looking at the parts of the sky that they could observe from their home base throughout the course of the year. But eventually we wanted to be able to map the entire sky. So the era of full sky charts really kicked off when Lalande again, he published in 1801 a document called the Histoire Céleste Française. He had 47,390 stars down to magnitude 9. So the deeper you go in faintness, the more stars you add to the list. So yeah, moving into the more modern era, we're in kind of the 1800s era now. We're starting to get people using telescopes to map the sky, they've got instrumentation that lets them accurately assign locations to various stars. So we get the German astronomer Friedrich Argelander. In 1875, he published a catalog with 325,000 stars. That's pretty good for kind of a single operation. He and a group of helpers or assistants basically used a telescope to catalog the sky. He was able to make a series of star maps, and he just used basically a coordinate system and plotted the positions of the stars. I put in my notes the word yikes when I saw this star chart, because I don't think that would help me too much if I had that on my observing table under the eyepiece. But hey, details are important. He captured them. So that's that catalog has been known as the Bonner Durchmusterung, or Bonn survey, taken from Bonn, Germany, and it's abbreviated as BD. So you might encounter that foundational star catalog, the BD or Bonner Durchmusterung catalog in literature, if you take a look for that. Now that only covered the sky from Bonn. So what are we going to do with the rest of the sky? Well, in 1886, another survey called the Südlich, or Southern catalog, added another 120,000 stars down to declination of 23 south. And then there was a Cordoba, Argentina survey done, published in 1892, which contained another more than 500,000 stars down to the southern celestial pole. And there was also work done at the Cape, Cape in South Africa, getting stars down there. So by the end of the 1800s, around 1896, these important scientific deep catalogs of stars were available. And then we hit the 20th century and enter the Yale University and the great Edward Charles Pickering's group working with the famous women computers at the Yale Observatory, compiling their star catalog compiled by primarily Annie Jump Cannon, among others. And that led to the Henry Draper catalog. So when you look at when you click on a star in something like Stellarium, you're going to see, a proper name if it's a bright star, maybe a Greek letter, maybe a Flamsteed number, but you're generally going to also see an HD code. So an HD and perhaps 6 digits. And that represents the Henry Draper catalog. That's what HD stands for. They cataloged the entire sky down to 10th magnitude. They've got upwards of 360,000 stars in that catalog, and so on. And so the work has continued on. We also have the SAO catalog. We also have the Hipparchus catalog, which is the HIP. And then Gaia, the Gaia telescope is currently mapping even deeper in the sky. So we're really getting lots and lots of detail, wealth of depth in the sky. But that's not the sort of thing we need for, amateur astronomy. We really don't look that deep, but it's good to know that, we've got that information at our fingertips. So most of the stars that we see, the coordinates are given in something like Stellarium. You'll see, let's see if we can pick one here. Here we go. You're going to see the right ascension declination, and typically that's given at an epoch. Let me just see if I can go back in here and add the full detail under information. Let's see, right ascension declination epoch. So there's a setting in Stellarium where you can decide which coordinate system you want displayed. Most go-to telescopes and star atlases are published using the so-called J2000 coordinate. So that's the year 2000. I'm not sure, Charles, if you know, I think I read somewhere that the next update might be 2050, the next sort of
I've heard that
change.
too. I don't know whether that is correct, but I've heard rumors to that effect.
Yeah. I mean, obviously the stars are drifting all the time, and they do vary from time to time. But I think most, go-to telescopes and things like that will have the math in there to interpolate from J2000 to J date. So you can see here in Stellarium, I've got for Razelhig, there's the right ascension and declination on the year 2000. So the hour 0 on the year 2000, this set of coordinates, and then they've also got the current set of coordinates, which could be, a little bit different, both because of proper motion and because of the Earth's precession, altering the coordinate system in the sky. So in terms of the atlases that we will use or want to buy to have by the eyepiece or by the telescope or with our binoculars, we can thank mainly 2 people, but there's really another one that's kind of fun as well. So the first one is Will Terrien. You'll see the name Will Terrien all over the place. He's a Dutch uranographer. So he's using the term uranographer instead of cartographer to suggest that he's mapping the night sky. He's responsible for something called the Sky Atlas 2000 that some people might have, the Cambridge Star Atlas series. I'll show a bit more of these in a little bit. And the Sky and Telescope atlases. I know I've got the Pocket. Charles has got the Jumbo. We'll come back and crack those open in a little bit. Some people might have an older atlas called the Norton Star Atlas. So Arthur Norton lived until 1955. He was a Welshman. And there's a really good, Charles, if you want to put that AdSab's link into the chat, it's a really neat paper on his history and what he did. I think he's a bit of an unsung hero. He produced Norton Star Atlas with a text supplied by another Brit named Ian Ridpath. And that Norton Star Atlas went through a number of iterations, but it seems to have kind of frozen out or leveled off. And then there's another fun one, and this is where I got my start, and that's this guy, H.A. Rey. He was a German-born American illustrator. He created Curious George, and at some point he decided that he wanted to depict the constellations and connect the dots in a different way that was maybe more intuitive. So he would take No, I think Leo the lion looks like a lion already, but he took Leo the lion and he added the legs and all kinds of things. He added, I think, for booties, he added the pipe, all kinds of funny little quirky elements to the constellations that make it fun. So he published this book called The Stars, A New Way to See Them. And that's a pretty substantial book, as you can see. And then the one that I got my start on was called Find the Constellations, which I got when I was, I think, 9 years old. I still have the original copy. It's all a little bit beaten up, but that just enchanted me. So if you know somebody who's young that wants kind of an enchanting little book on stars and stargazing, I recommend the H.A. Ray books. They're fun.
And he's on Stellarium too, if you want to see the skies.
Let's do that. So let's pop open the sky culture, and you can see here under the W for Western, we've got H.A. Ray as the second option here. Pop this open. And yeah, so I don't know if you noticed, but you know, the serpent bearer got a separate head. He's got arms holding the snake now. Scorpius looks about the same. Look at Sagittarius. So Sagittarius, what we call the teapot, which is buried in here, but these stars represent the bow of the archer. So you think he wants to make it look more like an archer. There's Aquila. Dolphin's a little bit more dolphin-like. Look at Cygnus. So he's given it a long neck. He's given it feet and broad wings. So it's fun. It's fun. So if you're, I don't know if I could navigate the sky now. I'm so used to the other, but it is a funny thing. There's Hercules in his club. There I go. There's Ophiuchus with his pipe sticking out. I remember that from when I was a kid. Oh, and the Great Bear. So he turned Ursa Major the other way around. So instead of this being the nose of the bear, he's now got Alcade at the tip of the handle of the dipper being the nose of the bear. I think that makes a fair bit of sense. Lots of fun. Highly recommend those ones. So in terms of making star atlases, we have to take the spherical sky, the globe of the sky, and map it onto a flat plane, be able to make it pages of the book or look at it on our computer screens. And so what we do is we use projection systems. Let me just put this back to regular Western. And if you're interested in playing around with projection systems, you can go into Stellarium, and on the Sky tab, at the bottom here, you've got all the different projections that you can use to project the stars in the sky. It's a little trippy, all kinds of weird and wonderful ways of looking at the sky. The ones we typically stick with are the stereographic. That's in there if you want, if you're curious about playing. So I put a link to, I'll just open up this link here so you can see the way we typically organize the sky. Is you can take the ball of the sky, or even the ball of the Earth, for example, and you can start with the North Pole, South Pole, and then split it into these, they're called gores or swaths, if you want. And they run, east to west around the sky. They pinch at the north-south. So if you can imagine cutting these out on a piece of paper and taping the little seams, they would assemble into a sphere. Those are called gores. And that's the basis for the organization of a lot of the sky charts. So if you look at the Pocket Sky Atlas from Sky Telescope, the beginning of each section, you've got the way they organize the sky into those gores from north to south. And then from there, in order to make these, into regular pages or panels of a star atlas, you have to subdivide them. So typically what you do is you decide on the scale of what you want to depict. You can then cut, say, a rectangular piece of this. And rather than skip the section outside the gore, you just extend the map a little bit. So you can have, missing stars, or you can actually just have the piece extended. In fact, for the Sky and Telescope, they take all the northerly tips and they assemble them into a ring. So you've got the ring around the North Celestial Pole at the north and south. As you move towards the equator, you can then start having one or two or more panels, subpanels within each of these gores. That's how they do it. And I'll talk a little bit more about how each atlas does this as we go. Now, what do we put on a sky chart? So let's talk about what we include. And I'm just going to bring up a sample. Do this. This hyperlink up. So the Sky and Telescope Sky Atlas actually was kind enough to post online sample charts. Normally we don't, for copyright purposes, we don't want to share people's star atlases on a stream like this on YouTube. But because they offer these samples of their sky charts as PDFs on their website, then I think I'm safe to show some of these here today. I'm just going to zoom in a little bit. There we go. So what have we got? We've got the stars are depicted using various sized black dots. The size of the dot is proportional to the brightness of the star in the sky. We've got the proper names listed for the main stars that have them. In the case of the Sky and Telescope Atlas, we've also got the Greek letters. So we've got the Bayer designation along with the proper name. And then we've also got the stars without proper names had their own Greek letters. Typically, the Greek letters work where alpha is the brightest star, beta, and so on down the list, with some exceptions to the rule. The deep sky objects are displayed using colored symbols. So in this case, the convention used in Stellarium, used in Sky Safari and apps like that would be, either a dotted circle for an open cluster, various diameters. Globular clusters tend to be a circle with a cross through it. Galaxies tend to be little ovals or ellipses, and so on. So you can see here we've got M12, M10. So the Messier objects will have their M letter plus their numerical designation. So as I said, M10, M12. The things like the index catalog, which is an alternate or an additional catalog beyond the NGC catalog, are given IC, so IC 4665. The ones that are just numbers, so you can see here 6348, so that's NGC 6348. So they don't need to bother putting the NGC everywhere. So if you see the numerical numbers without anything else, then you know those are NGC numbers. The Milky Way is usually expressed as either a shaded zone, and it may vary in intensity according to the strength of the Milky Way, or sometimes it's just the boundary line is drawn. Now the constellation names are generally plotted. So in here you've got Ophiuchus, you've got Hercules, but not always the line. So that's one of the things that you want to think about when you're thinking about buying a star atlas is, do you want the lines connected? Is that important to you? And as we saw from that, that busy sky chart a few minutes ago, there were no lines connecting the dots. But most of the main, popular star atlases like the Sky and Telescope ones and the Cambridge ones, they do have the constellation lines drawn. Some of them as well, they usually have a dotted line depicting the boundary between the constellations. That's helpful to have. And then a lot of them will have additional annotations to represent, double stars or variable stars. You can see here, I'm not sure on this one. So on the real Sky and Telescope atlas, you've got marginal key or legend that lets you understand the sizes of the symbols and what they look like. So you can see here Marfic's got a circle with a line through it. So that would represent that it's a variable star. And then you'll have some double stars that are things like a ring around them, the variable stars. What else we've got? So we've got coordinate system. We've got the right ascension hours. Generally most of these star atlases are organized so that the north celestial pole is up and the east, traveling east, celestial east would be to the left, west to the right, south to the bottom. Obviously biased for the northern hemisphere. I don't know whether Sky and Telescope or other publishers produce a southern hemisphere version of their star atlases. I'd be interested to know if anybody's aware of that. I'm not sure about that. So in this particular atlas, we've got a couple of hours of right ascension left and right, and we've got about 10, 20, 30, 40 plus degrees of declination up, down, or north, south. Now the ecliptic is generally plotted on the chart, not on this particular section of chart, but not the planets, because the planets are not going to be in the same spot every time you use the chart. So they suffice to put the ecliptic showing where the planets are gathered, but not where they're currently located. Let's see, I think that's about it. Oh, and the other thing that's helpful is that the adjacent chart numbers are indicated. So if you want to go north from Hercules as shown, then you want to look and change to page 52 or chart 52 in this particular case. I'll stop there and see if anybody had any questions or anybody typed in anything.
We have one in the Q&A. Bob Bellini saying west to the right.
West to the right. Did I not say that? Apologize if I didn't.
You did. I think you typed it in before you pointed that out, actually.
Oh, I see. Okay, great. Yeah. That'll actually come back with or affect us when it comes to using a sky chart at the eyepiece, where your telescope may flip the view. So, you know, I've got a tip there, but
okay, and Dan Hallett is asking if a J2000 the current choice on go-to settings. So is that, I guess he's asking, is that the current choice? Yeah, it is.
Yeah, that's a standard everyone's still using, and I expect that'll be the case for quite some time to come. Yeah, I think we're right. I don't think that they'll make any major changes until 2050. Got a good ways to go. All right, so let's talk about all sky charts. You know, all sky charts are by nature less detailed because you've got to fit more of the sky into a single page or single piece of paper. But they're really popular with astronomy magazines. Obviously, we had them in Sky News. They have them in Sky and Telescope, Astronomy Magazine, and so on. They're really handy, I find, for public outreach. So we'll get to planispheres in a minute. But, you know, if you want something inexpensive to just be able to hand out at a star party, there are places you can go to create tonight's sky, print that out as a black and white star chart. I'll demonstrate that here with the Heavens Above here in a couple of minutes. Now, the way that these work, just for those that might not be familiar, just to keep it basic, this is actually, by the way, a star chart or sky chart that the Calgary Center puts out. So I'm showing it, hopefully they don't mind. And they've got the current sky chart for July 2023. The perimeter of the circle represents the horizon, so ground level. The center of the circle represents the zenith. And then you've got your directions around the perimeter of the circle. Now, if you want to look at stars straight over your head, you can take this printout. You know, obviously you should have it printed out. Put it over your head and look up, and then you can rotate the piece of paper just to get the star patterns to match. But you'll have, you know, what's up in the sky depicted accurately with the bright stars. If you want to look at, say, the stars in the west, what you want to do is face west, take this circular chart and rotate it and put west at the bottom. And that way, the direction you're facing, these will be the stars in front of your face. Same for north, same for east. So whatever direction you happen to be facing, put that direction at the bottom, towards the bottom of as you're holding it. And then the stars, you know, between the horizon and 2/3 of the way up or so towards the center will be fairly accurately placed in your sky. Now these need to be made for a particular latitude. They're obviously made for a particular date and time, but they are usable on different dates because of the progress of the sky, 4 minutes worth every night. Then you can take a sky chart made for tonight at 11 p.m. and know that that's good, you know, in 2 weeks at midnight, that sort of thing, because as everything migrates across the sky. So you can hang on to them and just make note that if you're on a different date, that you've got to account for the different time that they're valid for. Typically, these will have the bright stars again, the connecting dots for the constellations and their labels. Some of them will have indicators for the bright deep sky objects, the more accessible ones, say the double cluster or the Andromeda galaxy, which would be sitting here. The neat thing about these sort of print to order or ready-made ones is that they're great for showing tonight's planets, tonight's moon, that sort of thing. And again, that's something that is going to vary, you know, a little bit. If you do tuck it away and want to bring it out in a couple of weeks, you know, the moon won't be in the right spot, but the rest of it will be fine. So let's talk about making our own. So if you want to make, this one is based on the Heavens Above tool. I'm just going to open this and bring up the Heavens Above tool here. So you want to start by making sure Heavens Above knows where you are. And what you can do is go to the main page here, the starting page for Heavens Above. Look for the astronomy section, look for the sky chart section. And the interactive sky chart is the one that I just showed you, the one that Calgary is using, I believe. Or maybe not, but that's fine. But I like to use the old version. I think this is the one that Calgary is using. So the old version lets you put in the year, month, date, hour, and minute. And what I like to do is I like to toggle this switch to make it black and white, maybe make it 1,000, depending on the size you want. And if you want it for tonight, you go into, let's say 2,300 tonight. You can add the ecliptic on here. If you want the constellation boundaries, click update. There you've got tonight's sky. And this is a great thing that you can then, you know, cut and paste, put on a handout, maybe add some additional notes about what to look for in the sky tonight, maybe some tips on how to use it, and you're good to go for touring people to the night sky tonight. So I highly recommend. I use this one a lot all the time. Sky and Telescope have an online chart as well. Let's see if this works here. Let's do this. Paste and go. So I'm not sure if there's a version of this which is kind of monochrome for printing out, but you know, you can take a look and see if that's, you could certainly get your current sky chart that way. I just don't know whether you'll get one that's as good for handing out as the other. All right, planispheres. So we also have the Rask Starfinder. We talked about this before on Insider's Guide as well. So if you go to the rask.ca/starfinder page, you can find a nice video on how to use them. And then you can find a way to order them to get the printed ones. So here's a Rask Starfinder ordered by a lot of the centers will order these and use them for handouts at their public events. But you can also download a copy of it in English or French. For example, if I go into the French here, that will let you print this out and assemble it together. So that's a great tool as well. It's a really nice service that Rask offers. Obviously, these are made for a particular range of latitudes. This one would be made, the Rask one will be made for typical Canadian latitudes. Now the planispheres are great because they're usable almost forever, basically forever. And again, they've got, I'm not sure if I have a bigger version of it here, but you've got the Milky Way indicated, you've got the ecliptic indicated. Again, the planets aren't labeled, but you've got the places where the planets are found indicated. And the way it works is you take the date, current date you're stargazing, and you rotate this big wheel until the date you're observing matches with the time that you're observing. And then the stars that are up in the sky will be shown in the window. And again, the directions are indicated on the perimeter of the cutout, and you'll just rotate it, pinch it so it stays on the same date time. And then you can view the sky there. I'll just show you another neat one. If you go to the Southern Hemisphere, you might want to get yourself a Southern Hemisphere planisphere. So this is one that I got when I went to Australia for OzSky. So that's kind of a neat thing to have handy. I'll stop again. Any questions, comments?
Somebody's saying, how do you view charts in the dark?
Good question. So the best charts will be designed so that they work under red light. So that's one of my helpful tips that I've got is when you're shopping for the star chart, you'll see that in the case of the Sky and Telescope one, I don't know if I still have the link here. Oops, where'd it go? Let's see what's in here. Here we go. The constellation lines, let me just go back to sharing again. There we go. The constellation lines are green, which means they'll be dark under red light. So they'll be visible under red light. All of the black and white material will be fine. The Milky Way may or may not be visible under the red light. That's not that important. But you'll find that the better quality charts will be made so that they work under red light. When I went into the bathroom the other day and tested a number of my charts with my red headlamp, I found that even the little red galaxy symbols on the were still visible. They're a little bit dimmer, but they're visible. But that's the benefit of buying a later edition of some of these star charts, is that people have pointed out any deficiencies there and made sure that they're all designed to work well. The other neat thing you can do is you may want to, if you're planning to use your star chart first as a way to find the objects that you're seeking in the sky, maybe with your binoculars or with your unaided eyes, you're going to be basically having your page in front of you, holding it up and kind of looking up into the sky. But if you want to use your star chart through the eyepiece, then you'll find that your telescope will flip, invert, mirror image the view. And one of the benefits of using a Dobsonian reflector telescope, for example, is that you can just simply take your star chart and flip it upside down, and it'll match the view through your eyepiece. If you're using an SCT, a Schmidt-Cassegrain telescope, or a telescope with a right angle prism on it, then it may mirror image the star chart. So you're going to be a bit out of luck. Now, that's where perhaps using an astronomy app might be a better help, where you can actually have a button that'll let you flip or mirror image the view. The other neat thing you can do is if you have your favorite star atlas, ready to go, you've purchased it, you can actually look for making a field of view template. I'll just show you here on the Sky and Telescope one. The Sky and Telescope one actually puts a reticle, a bullseye, on the margin of the cover, which you can then trace this out if you want to, and it'll work on all their star charts. The Cambridge Star Atlas and the Sky and Telescope Atlas, Charles, you've got the Jumbo Pocket Atlas. The image scale is a little bit bigger. It's about 30% bigger than the Pocket Atlas, but you can, find you can take one of these atlases, one of these margins, and get the degrees where you've got the subticks for the declination, for example, and you could use a compass or a set of circles and just make yourself a circle template of a certain field of view. So you might want to do one for binoculars, which would be bigger. And then if you've got something like a 1.5 degree eyepiece field of view, then you can make something smaller. Does it have the Telred in the Jumbo as well?
Yes, if
Okay.
you've got the jumbo version, just inside the front cover, there is the Telrad finder with the star magnitudes and the angular distance for the charts. So you can definitely use it. I think it's amusing that it's called a jumbo pocket atlas. This isn't going to fit in anyone's pocket, but I mean, this is what I use. But there's your information about Telrad.
So we'll get into a little bit more detail on some of these atlases here in a minute. This is the Uranometria. Look at it's two great tomes. It's a little bit like the that busy one that I showed you a little while ago. I don't typically use this one at the eyepiece much, but you'll find in this chart, the chart scales vary through the declinations on the sky. So one template won't work for the whole atlas, whereas with the Cambridge and the Sky and Telescope, I think you could make one template work for the whole atlas. All right, so let's just kind of go through a few of the recommended ones and some of the pros and cons. So highly recommend the Pocket and Jumbo Pocket, which I think is hilarious, version of the Sky and Telescope. These, this is written by Roger Sinnott, but it does use, I think, Will Tirian sky charts, our friend Will Tirian. It's 6.5 by 9 inches. It's goes down to magnitude about 7.6. So it's really geared towards kind of beginners, binoculars, small telescopes. It's not what you want for really deep detailed viewing. I've got about almost 31,000 stars in this atlas. They mark the double stars, they mark the variable stars. They actually have some carbon stars, which are the nice red stars that are fun to look at sometimes. They use the proper names, the Bayer Greek letters, the Flamsteed numbers down to about magnitude 5.5. The deep sky objects are shown using the symbols as I shared earlier on the screen, color-coded with the M for Messier's, the plain numerical for the NGC, and so on. And the magnitude limit of the deep sky objects varies according to the type of objects. So, you know, you won't have as many, say, nebulas as you will of other types. The sky is organized into 8 swaths, and the way they organize is they start at the North Pole, and as you turn the pages, then you travel down that gore and zigzag left and right with dual page spreads. The one disadvantage of this, though, is that if you're looking at a certain constellation and you want to go to the Western chart or the Eastern chart, you've got to jump by a large number of pages. So they're not, you know, not east to west, one after the other. I'll come back and explain why that's important in a bit. Then the jumbo is basically the same atlas. It's just enlarged by about 30%. So I think it's got, identical content. It's just scaled up. So you can confirm or deny that, Charles.
Yeah, no, it's basically the same. It's got the charts are just bigger. That's all. There's no difference. Why?
Well, you know, when you get older, your eyes aren't maybe as good, and you don't want to have to use glasses to read the chart. So why not 30% bigger? I mean, that's a good reason. Some people like to make notes on their chart, so having a bigger chart might be helpful as well. The Cambridge Atlas. So the Cambridge Atlas comes in 3 versions. So there's the Star Atlas, there's the Double Star Atlas, and then there's the Herschel Objects Atlas. It's basically the same charts. And what they've done is they've taken they've taken the same charts again by Will Tirian, and then they've added additional elements. So for the double stars, they've added the Washington Double Star Catalog. Not that deep, not the whole catalog, but the prominent ones. And then in the case like that, then the back half of the catalog, the back half of the atlas, is a list of the double stars for each constellation. So if you want to be studying double stars, that's a great one. But I find it for general purpose, it's a great set of charts, and I don't mind that it's got the double stars listed. The Herschel version of it is, instead of the double stars, it's got a number of the Herschel deep sky objects. So this one is, as you can see, it's bigger. It's about 12 by 9 inches. It's got 30 star charts. Again, organized or split using that swath or gore technique. But what's great about this one is that the charts, as you page through the atlas, you're paging east to west. So if you want to wait for, as the sky is crossing through the night, you're basically just flipping one page basically to go east and west. So it's a less page flipping than this. The facing pages are a nice swath of the sky. 2-page spread is 4 hours by 40 degrees north-south. So I really like it. The charts are a little bit larger than the Pocket Sky Atlas. It's a little bit deeper in terms of stars. You get a few more stars than you do. Goes down to magnitude 7.5, but I found that I have a few more stars on these charts than I did in the Sky and Telescope. Again, double stars, variable stars are indicated as before. And yeah, so there's that one. The next one I don't have, that's the Sky Atlas 2000. That's another Will Terry and Roger Sinnott one put out by Sky and Telescope. It's a great big 21 by 16 inch atlas. A lot of people used to have. I think it's maybe less popular now. You can get versions where the pages are laminated. You can get a version that it's white star dots on a black background and make it a little darker. You know, if you have a bright page when you're looking at dim objects, that bright white page can actually affect your night adaptation. So that's why having a reversed star atlas might be handy. It's similar in style to the Pocket Sky Atlases. Goes deeper, magnitude 8.5, and about 80,000 stars in that one. So 2,700 color-coded DSOs, plus some close-up views of busy patches of the sky, you know, Virgo cluster, Coma cluster, things like that. That one apparently has no constellation line. So I've seen some forum comments about it where, you know, a person will buy that edition and then painstakingly connect the lines the way they wanted them connected for the constellations. And then, oops, years later, I want to buy a new edition. I've got to go through and connect the dots again. So that can happen. And then last up here, Uranometria, which is that really deep atlas in 2 heavy volumes. 473 separate charts. That's why it's such a thick book. Again, 17 swaths or gores running north to south, stars to magnitude 9.5, doubles and variables. Larger DSOs are in here. No color to this one, so it works 100% for red light, but it's maybe not as pretty as you'd like. That's fine, but it's easy to read under red light. The constellation labels and the boundaries are here, but no dots, no lines connected. So I find that hard. I'm used to having the constellation lines. I prefer that. So other ones that I haven't actually used, maybe Charles, you have. I've used the Interstellarium Atlas.
I haven't got that one, no.
It's yeah, I don't know too much about it, but I see it. It's out of print, I think, but it's available.
Yeah.
Available used for $1,000 or some crazy amount if you go to Amazon. But keep your eye on, you know, Astro Buy Sell. Maybe somebody wants to get rid of that one. And then last up, there's some cool print-on-demand atlases that I've found over the years. So let me just bring up. I'll open up a couple of these here and show you what it looks like. So a neat one is the Deep Sky Hunter Atlas. Let me just open this up. And I'll share my screen. So this is actually a download. Charles, you can put the link to this in the chat if you want, at deepskywatch.com. So you can see here it's produced by Michael Vlasov, second revision from 2017. And it's a PDF, which means that you can actually print it out if you want to print it out. And it also means that as you zoom in, it redraws all the images, all the elements of the chart, so that it doesn't get fuzzy when you blow it up the way, you know, the way a JPEG or a bitmap would. So it just gives you sort of an idea of how it looks. It's 101 charts, covers the whole sky, printable, zoomable. I find that there's not that many star labels. I'd want more star labels. You can see here, there's Polaris, but hardly any other stars have their Bayer or Flamsteed numbers on them. So I consider that a bit of a thumbs down for that one. And as I said, you can get a version of it as well. You can download a version of it that's black background with white stars. And then I also noted one other was the Toshima Taki's Star Atlas that only goes to magnitude 6.5. So it would be kind of be equivalent, sort of an equivalent to the Sky and Telescope Atlas. All right, so that's what I was going to say. I'm happy to hear anybody's comments, suggestions. I haven't been watching the chat, so if anybody's got other suggestions.
Somebody was asking, are there transparent plastic charts for sale for backlighting? Like, for example, I know up at the Trotty Observatory, Vancouver Center, they've got 4 different black charts with white stars on them. They're backlit at night so that you can use them as charts for, you know, I imagine that's what Warren is asking here. I put a link in there for some clear plastic ones that you can find online, but have you found any use for those?
I haven't. I don't know whether the, for example, the Millennium Star Atlas that comes in a black, a white stars on black, whether it's single-sided or dual-sided, because if it was single-sided, then you could make a red light table. Right? You could have a piece of glass with some red LEDs under it and have it kind of shine through. That might be interesting.
Actually, maybe think of a conversation we had earlier where I was talking about Urania's Mirror, which is a publication from 1852 from London. And what it is a series of cards with the constellations drawn on them. And they recommend you take something and poke holes where the stars are on these, and then you hold them up to the light to see what the lights are going to look like. Kind of an early planetarium kind of an idea. So, I can understand why somebody might want to look at it that way.
Yeah, interesting. Yeah, okay. Cool.
So he's saying dew problems is one of the issues for sky charts.
Yeah, me personally, I'm an app. I'm a sort of a Sky Safari Stellarium app on a tablet. I like a tablet where it's bigger. I use my tablet with the red film, red gel over it. That way, if I get a notification or a pop-up, doesn't ruin my night app. My night
I
vision.
like Stellarium with a red background because that's one of the choices. Because you can put the red background in there.
Yeah, you can do that. I think I can do that here. Can I? I'm not sure if I have that available on my current Stellarium, but yeah, all the good apps have a red light mode, which is great, and I would recommend that. It's just that if you're on a phone and you get a text from somebody, that's going to come up white. So if you've got a way of putting red film on it, then you might be better.
Yeah, up at our observatory, we have a clear plastic box with a easy to open lid, and we put all of our star charts in there when we're not using them, so it keeps the dew off. We take them out as required. So
the Interstellarium, I think there are versions that you can get if you're willing to pay a little extra to have them laminated and they're field worthy, field ready. The Hunter Deep Sky Atlas, the one that I showed a minute or two ago, I actually printed them out. I had a big format printer, so I printed out a lot of the charts, and I could put them in a sleeve, like you know how artists will put their art inside a big sleeve, plastic sleeve. You can do that. So that's something you could get in an art store, a big format sleeve that you could put your chart into. But you'll find that the Sky and Telescope Atlas, I think the pages are coated. They're not laminated, but they are water resistant. So I think that they tolerate a little bit of moisture. Yeah, good point. Cool. I guess we can go on to our Finest NGCs.
Yeah, I was about to say, I think it's time for Finest NGC now.
So this is exciting because, spring is great, galaxies are great, but there's a lot of galaxies in the spring lists of Messier, Finest NGC and everything else. But today we're finally into summer. So we're starting the summer objects, and we've got a much bigger variety of types of objects. So let me just set up my stellarium for this, and then we'll press on. Right. Cool. Let's bring up my bookmarks. We'll set this to around 11 o'clock tonight, and I'm going to highlight all these here. There we go. Oh, I'll bring back my, there we go. So we've got a, tonight's sky, we've got a bright moon in the sky. So obviously I'm not going to recommend chasing down a lot of Finest NGCs for the next few days, but when we hit next Sunday night, we get the third quarter moon coming. So then the week, you know, the week and a half beyond Sunday will be ideal for jumping into these Finest NGC objects and the Messiers and all the deep sky objects of summer that summer offers. The sky gets dark, at least where I am in Toronto, around 11:30 p.m. But you can get started at 11 o'clock or so if you want to. And first up, we've got an object called the Turtle Nebula, which is up here in Hercules. So the little blue symbols are the ones we're going to cover today. Turtle Nebula, we'll just zoom in here. It's down here beneath the keystone of Hercules. So this is a small star-like blue oval planetary nebula. It's as bright as the Ring Nebula, but it's a lot smaller. But that makes it, because of its brightness, it's visible in most any telescopes if you can find it. Now, this one was not discovered by William Herschel. It was discovered by Wilhelm von Struve in 1827. And it's located 4.5 degrees. Sorry, my screen keeps blanking out here. 4 degrees northeast of the magnitude 2.75 star Beta Hercules or Coniferos. And it's in the direction of 51 Herc. So there's a little medium bright star, 51 Herc, kind of on the far side of it. Or what you could do if you want is to use the keystone of Hercules and just kind of double the span, the western span, and that'll put you a little bit to the west of the planetary nebula. That's another way of approaching it. Now, in terms of the object being a planetary nebula, it's benefits from the use of an oxygen-3 filter to brighten it up compared to the stars around it. So if you're not sure which object it is, since it is star-like at low power, put your oxygen-3 filter in, and all the stars, the true stars, will dim and the planetary nebula will remain brighter. You want to use lots of magnification though once you've found it, so 150 power or more, and you want to describe its size, any visible structure, and the surrounding field stars. I'm just going to zoom in on it here so you can see it, what it looks like. There we go. Cute little planetary nebula, really fun. Next up, we're going to jump to the south and go into Ophiuchus. Here we go. So you've got the cap or the head of Ophiuchus, and to the east of that, we've got two Finest NGCs sitting here. First up, we've got the Tweedledum cluster, which is the more easterly one. This is a real showpiece, and you can see here if I zoom in a little bit, it's nice and bright, and it sits beside this other big star cluster called Graff's cluster, or IC 4756, just to its east. So these two make a really nice sight in binoculars. So it's probably naked eye when it's nice and high on a clear moonless night. Definitely binoculars will work. Any size of telescope, but you don't want to magnify it too much because it's a large object. It was discovered by Jean-Philippe Lois de Chazot in 1746, and then again rediscovered later by Caroline Herschel in 1783. So it's located about 1.5 degrees south of, let me just wind out here. There we go. So if you take the bright stars, Almazan, or it's kind of the heart of the eagle, and Razelhag, which is the head of Ophiuchus, it's about 1.5 degrees below the midpoint between those. So that's one way you could kind of set your Telrad or your finder scope, you know, top edge midway between those two. You want to start at low magnification and then start zooming in. And as you do so, you know, count the number of stars, look at the different star colors you might see, look for any star patterns, pairings, chains, loops, things like that. And, you know, sketch the shape you see, for example. I don't know if, you know, in this case, I'm seeing kind of a letter S shape here on Stellarium, but.
Yeah, that's Captain Hook.
Yeah.
That's the hook with the sleeve at the bottom there.
So that's about, yeah, about 1,200 light years away. Nice. Thanks for pointing that out. Cool. All right. What else we got? Next up, a little bit to the west, we've got NGC 6572, which is the Blue Racquetball Nebula. This is another bright planetary nebula. It's again smaller but brighter than the Ring Nebula, which makes it accessible in any size of instrument, although it is going to be on the small side. You're going to need high magnification to see its structure. See, it's not a round ball. It's got a kind of a square rectangular shape to it. It's located 7.5 degrees east-northeast of Cybele. So let me just bring this up here. And if you've already found, you know, Graph's cluster and the Tweedledum cluster, you're kind of already, you know, in the right spot, because what you can do is kind of look for bright star, Cybele and the Graph's cluster, and this one's going to be above and between their midpoint. This one was discovered by von Struve again in 1925. And you can also look for these bright stars 71 and 72 Ophiuchi, a short distance above. That's about, let's bring this up. A couple of finger widths, 2.5 degrees to the north of the planetary nebula. This is another one where you want to use, you can use an oxygen refilter to brighten it with respect to the stars around it. And then once you've got it confirmed, you're going to want to crank up the magnification to see the details. You know, let me know if you see the central star. Be curious to know if you can pick up the central star on this one. This is about 5,100 light years away. All right, the next batch, I recommend waiting. So tackle these 3 first, and then tackle the next ones, you know, kind of towards midnight when they'll be higher in the sky. They're more culminating there. So first up, we've got NGC 6712. This is down here near the Wild Duck cluster. So Messier 11, the Wild Duck cluster, is sitting up here. I'll just bring up you can see the symbol for Messier 11. But what you want to do for this one, this is actually a nice little showpiece. It's a globular cluster. It's a class 11, or class 9 globular cluster. Dense enough to be visible in 7x50 binoculars under dark skies and really in any size of a telescope. Discovered by William Herschel on June 16, 1784, his class number 47 of his class 1 objects. And it forms an isosceles triangle below the bright stars Altair and Prior in Aquila, right? And then Beta Scuti. So if you could sort of make a imagine a triangle and aim your finder below and between them. Or you could extrapolate the lower half of the eagle by about 1.5 times or so in that direction, and you can pick it up using that technique as well. So this is the one that you're going to need a variety of magnifications to see if you can drill into its core, describe its shape, describe its sort of density profile. And by the way, if I just turn off the stars here, get a better sense of it. There we go. And while you're in the neighborhood, keep your eye out for this little green planetary nebula IC 1295 sharing the same field of view. There's the field of view. Oops. Let's put this in the center. There we go. And there's the little planetary just off the field of view. So you could actually tuck them both into the same eyepiece view. And don't forget, give the wild duck cluster some love while you're in the neighborhood. All right, next up, we've got the Little Ghost or the Ghost of Mars Nebula. And this one's down here near the bottom of Ophiuchus. And what's cool about this one, which makes this one easy to find, is it's sitting so close to the bright star C Ophiuchi, Garavsa, and so on. So that's kind of makes it really, really easy to find. This planetary nebula is in a bit of a quiet patch of the Milky Way, which helps a lot. So that makes it a little bit easier to see in most telescopes. It doesn't get very high for Canadian observers, unfortunately. This one was discovered by William Herschel back on May 21st, 1784, number 11 of his class 4 objects. And again, it's only a half a degree west-northwest of the bright star here. And you could also aim your finder at a span, let's see, I said, between Garavsa and B Ophiuchi. So you could kind of connect those two dots and then go about 50% further and you'll find it in that part of the field as well. Again, it's a planetary, so you want to use your oxygen 3 filter to zoom in. And the neat thing about this one is if you've got a larger aperture telescope and good sky conditions, you could reveal the TIE fighter wings on the east and the west of it. These little lobes that extend beyond it. This one's about 3,000 light years away. All right, up next, we've got the Box Nebula or Little Gem Nebula. So this is up to the northeast of that previous one. This is named for its unique form. And again, I'll just zoom in a little bit so you can see it's sort of a box shape. It's bright enough to see in any size of quality telescope, discovered by William Herschel on May 28th of 1786, number 586 of his class 2 objects. And it's kind of near Messier 23, which is a bright Messier object. There's Messier 23, just put on the symbols here. There's M23. So it's actually located just a couple of fingers width or 2 degrees to the southwest. You can also look for the, let's see, the bright stars nearby, C Ophiuchi, too. So you can actually extrapolate kind of up from the foot of Ophiuchus through C, and it's about 1.5 times the span. So that's another way you could locate it. Now it is in a bit of a busier patch of the Milky Way, so you want to use your oxygen 3 filter to let it stand out against the background. And then once you've got it, you can crank up the magnification and look for its structural details, look for the central star. And there's also a little globular cluster in the neighborhood as well. NGC 6440 sitting just to the south of it. This one's about 4,500 light years away. And last up, we've got the Dead Man's Chest or Castaway Cluster. Just turn off this Messiers here. Here we go. That's down here near the spout of the teapot stars of Sagittarius. 6520. Just select that and zoom in. Here we go. This is an open cluster. It's small, it's rich, and it's sitting right beside a little hole in the Milky Way, a little dark spot. The little dark spot's called Barnard 86, or the Ink Spot Nebula, or Herschel's hole in the Milky Way, or hole in the heavens. So if you've got good sky conditions and you found the cluster, see if you can see this sort of empty little patch just to its west. This one can possibly be picked up in 7x50 binoculars and any size of a telescope. Again, it's another one that culminates, not very high for Canadians, but try to get it. This one culminates right around now, after midnight, so 12:30, 1 a.m. in the morning. It was discovered by William Herschel on May 24th of 1784, number 7 of his class 7 objects. And it's located So either you're going to use the teapot stars to find it here. So it's 2.5 degrees north of El Nazle. So if you can find El Nazle, just go 2.5 degrees up, maybe 1.5 sort of fields of view of your low power eyepiece. Or I said you could connect the line connecting Namosadira 1 and the tip of the teapot here to Sagittarii. So if you sort of make a line connecting those and just find that line, but directly due north of or directly above El Nazle, then you should be able to pick it up that way. So this is a, you want to use about, 65 power is probably a good power to use on this one. Just bring up my eyepiece field of view here. There we go. There we go. And you want to, remark on the shape, the number of stars, the colors of the stars, the density of the cluster, that kind of thing. And then don't forget to look for the hole. So this one's about 4,800 light years away. So that's it.
Fabulous.
Any questions? Obviously, lots of other things to look for in the Milky Way, but plenty of Messiers and things to look at. But if you do want something a little bit different, then check out these suggestions from Alan Dyer.
Fabulous. Don't have any questions? Last call for questions? Looks like we have done the job here.
So we've got 2 more groups of Finest NGC to finish the whole set, but we're going to have a break. We're going to come back at the end of the month with a visit to York University's observatory, which they're kind enough to offer us to have an on-site session. So that'll be fun. And then we'll come back at the end of the summer for our final group of NGCs. I think we've got a plan to look at exoplanets for that one.
Great. And if you're interested in reviewing all of this stuff from today, we'll have them up on YouTube. Take a look here in a couple of days.
Nice. Well, thanks for tuning in, everybody. Have a great summer. Wishing lots of clear skies. Moon will get out of the way in a week, and then we'll be back to fun Milky Way stuff. So,
all right.
take care. Bye.